Alright, welcome back to the second part of this exercise. And in the first part, I introduced the concept or the techniques of substitution. And here in the second part, we look at how we use the technique to tackle some integration problems. Let's start with the first one, A. And if you think about it, you probably realize that the one at the top, this numerator, is actually a result of differentiating the denominator. And as you can see, if you have y equals to x squared plus 1, and dy dx will be 2x, which is what at the top of the this rational expression. And so we are pretty confident that if we substitute x squared plus 1, which is the antiderivative of 2x, will transform the problem to something more simple looking. So let's try that. Let u be x squared plus 1 and differentiate it. And we do this simple step, cute little step, for a very good reason. I'll show you later why. And we are ready to perform the transformation. But before that, I'm going to group 2x and dx in brackets. The reason is, now you see that the x squared plus 1 is actually u, after the substitution, and the 2x dx is actually du. So if you perform the substitution right now, you have 1 divided by u, and this 2x dx is in fact du. And this complex looking integrations, integral would now become something simple, simple looking. And we know if we integrate this is ln u plus c, and of course do not forget u is x squared plus 1, right? And that's it. That's this answer and the solution of doing this. And you want to check whether you're correct or not. What you do is you differentiate your answer and check whether you would actually get this back. That's one way for you to check. Now, part D, I would advise you now you stop the video and then you attempt it yourself. And you can then continue watching the video. I'm going to do it pretty quickly without much explanation, right? Okay, and I chose to substitute x cubed minus x by u. And this factoring the 2 for a good reason. See, this is 2 is still going to be there, but the 3x squared minus 1 dx is in fact du. And this is actually u, x cubed minus x is u. So this is the result is ln absolute of u plus c. Not to forget that actually u was this one to begin with. Then there you have it. I'm gonna move on to another type of integration problem. See this, we're going to attempt D, and then I give you a hint on how to do part A, right? So what we're going to do is first begin as follow. You think about it, you probably realize that the 1, if you differentiate 1 minus x squared, you get negative 2x, right? See, let's check this. You differentiate this, you get negative 2x. Fine. The key is that, okay, we see x here and we see x here, so this probably gives us a hint on how we proceed, and we're pretty confident if we substitute the 1 minus x squared with u, you probably going to make this become simple. So now f prime is this. Of course, the fx is equivalent to this, e minus x squared dx. Integrating the expression, you get what you need. So what we do now is we let u be 1 minus x squared, and of course du minus 2x, of course du dx, and so du is actually minus 2x dx. And I'm going to stop here for a moment, but we continue with this integration. Alright, so x e. I'm not done yet with this part. Right. Now I observe that if I do a little bit of switch. No, be careful. This is actually x squared. So you have x dx here. However, I don't see x dx anywhere. Oh wait, what we do is over here x dx. So therefore, if I do one little cute step like this, I multiply both sides by negative half. So we have negative half du equals to x dx. The right hand side, the negative 2 would be eliminated. And so if I perform the substitution, you get a e u. Remember that u is in 1 minus x squared, and this becomes negative half du. Really cute little thing. And negative half is just a constant. I can put it in front and just focus on the integration, and voila, I will have negative half eu, right, plus c. Okay, and of course u was 1 minus x squared to begin with, so there you have it. Okay, now and try the part A, but I'm just going to give you a hint. Notice that if you differentiate 3 minus x cubed, you actually get x squared. You don't get x squared, but you get negative 3x squared. As you can see, why 3 minus x cubed. And if you differentiate this, you get negative 3x squared. The key here is the x squared, which is a pattern that you observe in front of the expression in bracket. So it's fair to say that, or I should say that we're pretty confident if we let u be 3 minus x cubed, we should be able to get what we need. So that's my hint. You should try it and then check the answer at the back.